So today, the other videos I'm going to make are 3 short videos showing you how to answer slightly different questions that are a wee bit trickier, and just using that distance formula in slightly different ways. Just to get a feel for what's going on, I'm going to sketch my 3 points. We've got 8 along 2 up, 11 along 13 up, and 2 along 6 up. Now it's not an accurate picture, but just gives me a sketch of those points. So that was A, and that was B, and that was C. So as we work things out, we can add it to the diagram. At the moment, it's not entirely obvious which sides are going to be the same, but we want to show 2 of them, exactly 2 of them are the same. So let's work out all of our different things. So the first thing we're going to do is work out length AB. And remember, we can just plug that in our distance formula. So that is going to be 1 take away 8, all squared, add 13 take away 2, all squared. Working that out, we end up with 3 squared, and 13 take away 2 is 11 squared. 3 squared is 9, 11 squared is 121. So altogether, we get the square root of 130. I'm going to leave it like that. This is where having things in third form is dead easy. You can still compare if 2 things are the same or different when we've got them in third form. So we don't need to turn that in decimal in any way. We're going to work out a second pair. Let's do length AC. That's the square root of, now my numbers are off the top of the screen, but you can go back and check. We have 2 take away 8 squared plus 6 take away 2 squared. That gives us minus 6. Now be careful to put that in brackets because we're squaring all of the minus 6. And that one gives us 4 squared. Working that out, we get the square root of 36 plus 16, which is 52. Square root of 52. So these 2 sides are definitely not the same. Finally, length CB, and this time we've got the square root of 11 take away 2 all squared plus 13 take away 6 all squared, and into the square root of 9 squared plus 7 squared, and lo and behold, 9 squared add 7 squared is 130. Now, you might be tempted to stop here. Please don't. Please finish the question off. We were asked to prove that something was isosceles, so let's justify that that is the case. So as AB equals CB, either are the same as AC. That's important because if one of these was the same as AC, or both of them therefore would be the same as AC, we'd have an isosceles triangle. An equilateral triangle, but we want to show this is isosceles. Then I'm going to use the little shortcut symbol. That means triangle ABC is isosceles. So it's just nice to write a sentence that convinces we've got 2 sides the same, but not a third, and so we have an isosceles triangle. And that finishes our question. Now the other 2 questions are going to be similar sort of style, but just again using that distance formula in a slightly different way.